Welcome to my viewers once again. Today we'll discuss about set theories. The concept of set was originally developed by a famous German mathematician George Cantor. The idea of set is widely used in mathematics nowadays. In every now and then we will discuss about the idea of sets. We will find the relationship between number systems. Say for example natural numbers, whole numbers, integers, rational numbers, irrational numbers, and then real numbers. The relationship between these numbers would be described in more meaningful way if we know the idea of sets. Sets, the concept of sets will be used in defining relations and functions in mathematics. Now, what is set? Let us define set. A set is a well-defined collection of distinct objects. Now, there are two keywords here, well-defined and another is distinct objects. Now, what is meant by well-defined? Say, for example, if I ask you, what are the square roots of 1? Square roots of 1 means there are two roots of 1, square roots of 1. One is plus 1 and another is minus 1. That means you have distinct replies against this statement. So, this statement is well-defined. Similarly, square roots of 25, answers are plus 5 or minus 5. You have distinct objects against this statement. Now, what is not well defined? Say, for example, roots of 1. This statement is not well defined because it is not specifically mentioned whether it is trying to mean square root or whether it is trying to mean cube root of 1. Similarly, the most beautiful girl of the world. The definition of most beautiful is different for different people. So there is no specific reply against this statement. Similarly, the set of Pandavas, it is well defined. If I ask you who were the Pandavas, definitely you will say Yudhishthira, Bhim, Arjun, Nakul, Sahadev. So there are specific and distinct replies against this statement. The set of even numbers 0, 2, 4, 6, 8, etc. are called even numbers. So you find that the elements of these sets, each of elements of this set are different from one another, distinct, right? Now, when we define a set, you will find some objects or elements. The things you find within a set are called objects or elements. When we say the set of integers, you will find these numbers minus 3, minus 2, minus 1, 0, 1, 2, 3, etc. These are integers. Similarly, when we say the set of even prime number, then you will find an object. Answer is 2. This is called element of the set. Now, when we find any object or element within the set, we use this symbol belongs to. Now, when we define the set of even numbers 0, 2, 4, 6, etc., then we find that 0 is an element of this set. So we say 0 belongs to E. Similarly, 2 is an element of this set. 2 belongs to E. Now, number 1 is not belong to this set. This is the set of even numbers. 1 is an odd number. So 1 not belongs to E. 3 not belongs to E. 5 not belongs to E, etc. Right? So the symbol belongs to means when we find an element within the set, we will write the element belongs to that set. And if we don't find any element, we say, for example, 1 is not belong to this set. So we write 1 not belongs to E, 3 not belongs to E, 5 not belongs to E, etc. Now, representation of sets. Let us discuss how will you represent a set. There are two ways of representing a set. one is roster form or tabular form. In roster form, you will write the elements of the set within braces separated by commas. Say for example, the set of odd numbers, you will write what are the odd numbers, 1, 3, 5, 7, 9, etc. So we will write the elements separated by commas and will be written within braces. This is called tabular form or roster form. Similarly, the set of Pandavas, you will write the elements of this set separated by commas, Yudhishthir, Bhim, Arjun, Nakul, Sahadev. Right? Now, second method is called set builder form. Now, in set builder form, we generalize the elements of the set with a symbol or variable. Say, for example, the set of integers. Integers are -3, -2, -1, 0, 1, 2, 3, etc. Right? So we generalize these elements by a symbol. Say, for example, we will write symbol X for integers. Now we will use a symbol colon symbol here, then write here what is trying to mean by X. X is an integer. So integer can be written as X such that X is an integer. Here X is trying to mean the integers. It's a general symbol for integers here. Similarly, say this set P, it is in tabular form. 2, 3, 5, 7, 11, 13. These are prime numbers. Now, if we denote these prime numbers by symbol Y, we will write in our set builder form Y such that Y is a prime number. So, elements of the set can be represented in two ways. One is roster form or tabular form, and another is set builder form. In roster form, the elements are written within braces separated by commas. In set builder form, you will generalize the elements of the set by a symbol, and you will define what is trying to mean by that symbol. Right? Now, cardinal number of sets. Now say, for example, A is a set. There are two elements, 2, 3. Now we write this as NA equal to 2. There are two elements within this set. Similarly, if set B, suppose -3, -2, -1, 0, 1, 2, 3. Now, how many elements are within this set? There are 1, 2, 3, 5, 4, 1, 2, 3, 4, 5, 6, 7 elements. So NB equal to 7. So cardinal number of sets means the number of elements within the set. We write it as NA means number of elements. How many elements are within this set? 2 elements. How many elements are within this set? 7 elements. Now, sometimes you may not find any element within the set. Say, for example, the set of prime number less than 2. Now let us denote this set by say Y. Now, will you find any prime number less than 2? There is no prime number less than 2. So the cardinal number for this set is 0. Means there are no element within this set. 0 elements. Now let us define empty set. Empty set means the set which does not contain any element. Say for example, the even number between and 3. Is there any even number between 2 and 3? Answer is no. So if you denote this set by say D, you will find there is no element within this set. So this type of set which does not contain any element, we call this empty set or null set or void set. There is a symbol for empty set. This symbol is phi. Phi means this is equivalent to no element within the set. Phi means there is no element. Now singleton set. Sometimes you will find only one element within the set. Say for example the set of even prime number. Now within this set, what is even prime number? Answer is 2. So cardinal number of this set is 1. There is only one element. If we denote this set by suppose B, you will find that NB equal to 1. This set is called singleton set, only single element. Similarly, say for example the largest 2-digit number. What is the largest 2-digit number? Answer is 99. So there is only one element within this set. So it is a singleton set. Now another is finite set. Means the elements of the set are countable. Finite number of elements. Suppose example A equal to 2, 4, 6, 8, 9. Now there are how many elements? 1, 2, 3, 4, 5. 5 elements. And A equal to 5. It's a finite set. Countable. Now infinite set, say for example the set of natural numbers 1, 2, 3, 4, 5, 6. So there are infinite numbers of natural numbers. This set is called infinite set. Similarly, set of even numbers 0, 2, 4, 6, 8, etc. Set of real numbers, the set of real numbers, these are called infinite set. Next we will discuss equal sets. Say for example there are two sets, A equal to 2, 3, 5 and B equal to 5, 2, 3. Now you see both A and B are equal because they contain the same elements, right? So we call them equal sets. They are equal. Now equivalent sets. Say for example A equal to 2, 3, 5, B equal to suppose 1, 2, 3. Now cardinal number of A equal to 3. There are 3 elements within this set. Cardinal number of B equal to 3. Now A and B are said to be equivalent. A is equivalent to B, or we will write it as A equivalent B. So equivalent means in terms of cardinal number they are same, but equal means they contain the same elements, right? So equal and equivalent, you should not get confused. Equal set means two sets are said to be equal if they contains the same elements. And equivalent set means the cardinal number are same. They contain the same number of elements, but not exactly the same elements. Now we'll discuss subset and superset. Now say for example A is a set. It is starting with 0, 1, 2, 3, 4, 5, etc. That means the set of whole numbers. And B is a set 1, 2, 3, 4, 5, etc. This is the set of natural numbers. Now we say that B is a subset of A because every element of B is also an element of A. So we call B is a subset of A. And conversely, we'll write A is superset of B. So subset means it's a mutual relationship between two sets. You find that every element of set B is also an element of A. So we call B is a subset of A. And conversely, A is called superset of B. Similarly, say whole number we refer as 0, 1, 2, 3, 4, etc. Integers we will write it as -3, -2, -1, 0, 1, 2, 3, etc. Now you see every whole number is an integer. That means any element of this set you will find within this set. Every element of this set is an element of this set. So write it as W is a subset of I, or I is superset of W. Right? Now let us try to solve some exercise here. Which of the following statements are sets? Justify your answer. We are taking these examples from Cbse curriculum. The collection of all months of a year beginning with letter J. Now for this question, this statement, collection of all months of a year beginning with letter J. Now January, then June, then July. These are the months starting with J. So this is well defined. You got distinct elements for this statement. So this is a set. This is an example of set. Let us denote this set by say J. So J denotes the set which describes the months of the year starting with J, capital alphabet J. Well defined. Example 2. The collection of 10 most talented writers of India. Now, most talented writers of India. The idea of most talented writers, it is different for different readers. For me, if somebody is talented, he may not be talented for other readers. So this statement is not well defined. So their statement is not well defined. Right? The most talented writer may vary person to person. There are no specific answer for this statement. There are no specific answer for this statement, right? The most talented writer may vary person to person. Statement 3. A team of 11 best cricket batsmen in the world. Now the best cricket batsman, this statement, it is also not well defined, because the best cricket batsman for selectors, it depends on person to person, right? So the batsman who is most talented for me may not be most talented for some other people. So you cannot give specific reply, distinct reply for this statement. So it is not set. It is not set. This is also not set. The collection of all boys in your class. It's a set. The collection of all boys in your class. You can in tabular form you can write the names of your friends, classmates. If there are 40 students in your class, so you will find 40 elements for this set. So it is a well-defined statement. We will call it as set. The collection of all natural numbers less than 100. This is also well-defined. The collection of all natural numbers, right? Say if you denote this set by A, you will find 1, 2, 3, 4, 5 up to 99. So this statement is well defined. Distinct elements are found. A collection of novels written by writer Munshi Premchand. This is well defined. The books written by him, novels written by him, you can identify. The collection of all even integers. This is well defined. It is a set. Even integers, right? The set of even integer means 0, 2, 4, 6, etc. So it is well defined. The collection of questions in this chapter. So you can find questions in this chapter. Say for example, there are 9 questions here. So you can enlist the numbers here. So it is well defined. The collection of most dangerous animal of the world. It is not well defined. If I say snake is the most dangerous animal of the world, somebody will say lion is the most dangerous, right? So someone will say like elephant is the most dangerous animal of the world. So it is not well defined. The most dangerous, this term is not well defined. It is not trying to give specific reply. Person to person answers will vary. Question number 2. Let A equal to 1, 2, 3, 4, 5, 6. Insert the appropriate symbol belongs to or not belongs to in the blank spaces. Now, the element 5 is within this set. We say 5 belongs to A. 8 not belongs to A. 0 is not within this set. 0 not belongs to A. 4 belongs to A. It is within this set. 2 is also element of this set. 2 belongs to A. 10 is not belongs to this set. 10 not belongs to A. So belongs to means the element is within the set, and not belongs to means that element is not within the set. Question number 3. Write the following sets in roster form. So what is roster form? In roster form or in tabular form, the elements are written within braces separated by comma. So question number 4.1, A equal to, it says that x such that x is an integer and it lies in between 3 and 7 including 3. X greater than equal than 3. That means x is equal to minus 3 and greater than minus 3. So minus 3 is an element of this set. Minus 2, minus 1, 0, 1, 2, 3, 4, 5, 6, right? Last element is 6 because it says x less than 7. X is an integer less than 7. So any integer less than 7 and but greater than or equivalent minus 3, these are the elements of this set, right? Answer 2, b equal to x such that x is a natural number less than 6. So you write the natural number less than 6. 1, 2, 3, 4, 5. These are the elements of this set. Writing in this way is called roster or tabular form. Answer 3, c equal to x such that x is a 2-digit natural number such that sum of the digits is 8. Now, can you find 2-digit natural numbers? Sum of the digits is 8. So 2-digit natural number starting with 10. Sum of the digits 1 plus 0, 1. 10 equal 1 plus 0. 11, 1 plus 1, 2. 12, 1 plus 2 equal to 3. So sum of the digits should be 8. So what would be the first element? 17, right? Then after 17, 26. Sum of the digits 2 plus 6, 8. Then 35, 3 plus 5, 8. 44, 4 plus 4, 8. 53, 62, 71, 80, right? These are the 2-digit numbers. Sum of the digits 8. 1 plus 7, 8. 2 plus 6, 8. 3 plus 5, 8, etc. D equal to x such that x is a prime number which is divisor of 60. Now you find the prime numbers divisor of 60, factors of 60 which are prime numbers. So you find factors of 60, 1 multiplied by 60, 2, 30, 3, 20, 4 into 15, 5 into 12, 6 into 10, right? Now define the prime numbers. 2, 3, 5. 2, 3, 5. These are the prime factors of 60. Question number 5. E equal to the set of all letters in the word trigonometry. So you write T, R, I, Z, O, N. Again O, since we already enlisted O, so we will not repeat. M, E. Again T already enlisted here, we will not repeat here. R is already enlisted. Y, last is Y. So you understood what is meant by distinct elements. Distinct means every element should be different from one another. So we cannot repeat 0 or O 2 times or T 2 times here. Similar R 2 times, we cannot write R 2 times here, right? Number 6. The set of all letters in the word better. So all letters, alphabets, B, E, T, again E, so R. We will not repeat this same alphabet. So E is 2 times, we will enlist here 1 time. T here 2 times, we will enlist here 1 time only. By definition of set, a set is a well-defined collection of distinct objects. So if we write T 2 times, that means they will not be distinct, same thing. So we cannot write identical things 2 times. Now question number 4, write the following sets in set builder form. This set you see 3, 6, 9, 12. Now let us try to generalize these elements. These multiples of 3, right? 3 1s are 3, 3 2s are 6, 3 3s are 9, 3 4s are 12. So all these numbers are multiples of 3. Now can we generalize these elements? How will you write 3 multiples? 3x suppose, where x is any natural numbers, right? So we generalize these numbers as 3x such that x equal to 1, 2, 3 and 4. This is well defined, right? If we put x equal to 1, you will get first element. If we put x equal to 2, you will get second element. X equal to 3, 3 3s are 9. X equal to 4, 3 4s are 12. So this is called set builder form. We generalize the elements by symbol. So we'll write it as 3x such that x equal to 1, 2, 3 and 4. Now question number 2, 2, 4, 8, 16, 32. Now see the common properties. How can we generalize the properties involved within these numbers? 4 is 2 times of 2, 8 is 2 times of 4, 16 is 2 times of 8, 32 is 2 times of 16. So you will see that every successor is a twice of predecessor, right? So you see, if you generalize these elements like x such that x is twice of one, 2, 4, 8, 16. X such that x is twice of 1, 2, 4, 8, 16. Now twice of 1 is 2, twice of 2 is 4, twice of 4 is 8, twice of 8 is 16, 16 is 32. So x is such that x is twice of 1, 2, 4, 8 and 16. Similarly, question number 3, 5, 25, 125, 625. You see, 5 5s are 25, 25 5s are 125, 125 5s are 625. That means every successor is 5 times of the predecessor. So let us denote these elements by say 5y such that y equal to 1, 5, 25 and 125. So if you put y equal to 1 here, 5 1s are 5, 5 5s are 25, 5 25s are 125, 5 into 125, 625, right? Similarly, you can define this set also. You can write it as twice x such that x equal to 1, 2, 4, 8, 1, 2, 4, 8 and 16. So if you put x equal to 1, you get first element. If you put x equal to 2, you get second element. If you put x equal to 4, 2 4 is 8, third element. X equal to 8, you got fourth element. If you put x equal to 16, you will get fifth element. Similarly, question number 4, 2, 4, 6, dot, dot, dot. Now, how do you write in set builder form? Let us generalize these elements. These are even numbers greater than 0. So let us denote these elements by twice x, such that x equal to 1, 2, 3, 4, etc. Now if you see x equal to 1, you will get the first element. X equal to 2, you will get the second element. X equal to 3, third element, and so on, right? Or you can write it as twice of x, such that x is a natural number. So if you multiply a natural number by 2, you will get an even number. So twice x means any natural number. So if you multiply any natural number by 2, you will get even number. Now starting with 1, you will get first element 2, twice x, 2 into 2, 4, x equal to 3, 2 3 is 6, third element, and so on. Now question number 5, 1, 4, 9, dot, 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 100. Now you see find square of 1 is 1, square of 2 is 4, square of 3 is 9, then finally square of 10 is 100. So all these numbers are square of the natural numbers 1 to 10. So we will write it as x, such that x is a square of first 10 natural numbers, right? X is a square of first 10 natural number. So first natural number is 1, square of 1 is 1, second natural number is 2, square of 2 is 4, third natural number is 3, square of 3 is 9, and so on. The 10th natural number is 10, square of 10 is 100. This is how you can write in set builder form, right? Thank you viewers for watching this video. We will discuss about set theories in the next class again. Thank you.